This video is on binomial expansion. Before we get into that, I want you to have a go and see if you can expand each of the 5 brackets on the left-hand side of the screen. So pause the video and have a go at each of those. Okay, welcome back. You should have had a go at expanding each of those 5 brackets on the left. And they are binomial expressions because there's 2 parts, 2 terms inside the bracket. Now the first one's nice and easy because it's just x plus y, because to the power of 1 you just get that thing. X plus y squared, we need to remember that that is x plus y, x plus y. That's 2 brackets, and we have to multiply out those quadratic brackets, but again shouldn't cause too much trouble to get to x squared plus 2xy plus y squared. The next one, you want to spot that this is x plus y squared times x plus y. So everything in the one above we need to multiply by x and by y and then simplify. And we get x cubed plus 3x squared y plus 3xy squared plus y cubed. The next one, we need to spot that it's x plus y to the 3 times x plus y. So we multiply everything in the one above by x, multiply it all by y, and then simplify, and we get this expression. And finally, x plus y to the 5 is x plus y to the 4 times x plus y, multiply everything in the one above by x, everything by y, and then simplify to get this expression. So those are the 5 answers. Check those against the ones that you got. But what we're most interested in here is actually looking at the coefficients. The coefficients are the numbers that multiply each term. That's 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, and 1. And there's lots of patterns in these triangular red numbers. 1, for example, is all the first and last numbers are 1. Another, every row is symmetrical. And a third one that's really useful is how to make it. And that is that any number is the sum of the 2 numbers above it. 3 is 2 plus 1. 2 is 1 plus 1. 6 is 3 plus 3. 4, 1 plus 3. 10, 4 plus 6. 5, 4 plus 1. And any number in Pascal's triangle, that's what this is, Pascal's triangle, is made that way. And Pascal was a French mathematician. He didn't come up with this triangle, but he did sort of make it popular. And there are lots of patterns in Pascal's triangle, and we're going to use this to help us expand these binomial expressions more quickly than having to write out all the brackets. So let's jump into some examples. So we can use Pascal's triangle to help us. And what we do is we use the relevant row of the triangle. And we get that by looking at the power of the bracket we're expanding. So in this case it's 7. So we're going to be using row 7. And we write out that row. 1, 7, 21, 35, 35, 21, 7, and 1. Next, we look at the first term, which in this case is a, and we write that in decreasing powers. So we start with a to the 7. And then we decrease the power by 1 each time as we go through, putting 1 under each of the terms of Pascal's triangle for that row. And it will always perfectly match up with the last one being a to the 0. The next step is to look at the next part, the second part of the binomial, and we do that in increasing powers. So we start with b to the 0, and again this time we increase, but we go along matching up every one as we go. Increase the power by 1 each time until we get to the last one, which is b to the 7. Now one very important thing to notice here is that the powers of the a's and the b's always add up to the total power 7. And they will always do that. The powers, pairs of powers will always add up to the total power. And then all we do is multiply down each column and add together the results. So multiply down, we get a to the 7, and then add. Multiply down, 7a to the 6b, and add. Multiply down, and add. Multiply down, add. Multiply down, add. Multiply down, add. Multiply down, and add. Finally multiply down. We just get 3 to the 7 in the last term. And that is our expansion. If we were to expand a plus b to the 7, the longhand way, multiplying lots of brackets, we would get the same answer. This is a quicker way of getting there using patterns in Pascal's triangle. So let's have a look at a slightly more complicated example where it's not just a and b. We can still use this method. So we first of all look at the relevant row of the triangle. Power is 4, so it's the 4th row here. And we write out 1, 4, 6, 4, and 1. Next, we look at the first term, which is 2a, and we take decreasing powers of that. So it's 2a to the 4, 2a to the 3. And it's important that these are in brackets. The whole of the term is to these powers. Next, we take the second term, minus 3b, and we must include that minus, and we get increasing powers. Again, we must put the whole term, minus 3b to the 0, minus 3b to the 1, minus 3b squared, minus 3b cubed, minus 3b to the 4. Now each of those second and third rows we can simplify. 2 to the 4 is 16, so we get 16a to the 4. 2 cubed is 8, so we get 8a cubed. 2 squared is 4. Anything to the power of 1 is just itself, and anything to the power of 0 is just 1. Do the same on the bottom row. Anything to the 0 is 1. Anything to the 1 is itself. Minus 3 squared is 9. Minus 3 cubed is minus 27. And minus 3 to the 4 is plus 81. Now we do the same thing. We multiply down and add together. So we multiply down the first one and we get 16a to the 4. Multiply down the second one and we get minus 96a cubed b. Multiply down the third one, we get plus 216a squared b squared. Multiply down the fourth one, we get minus 216a b cubed. And finally, multiply down the last one, we just get 81 b to the 4. So that is the expansion of 2a minus 3b to the power of 4. And that's how we use Pascal's triangle to help us expand binomials. We write out the binomial expansion, the coefficient, the Pascal's triangle row. Then we write out the first term in